Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Codes, DTC P0966 and P0967, relate to the continuously variable transmission, CVT, in the Honda Civic from model years 2016 to 2021. DTC P0966 indicates a low voltage issue within the CVT-driven pulley pressure control valve circuit, while P0967 points to a high voltage situation. These error codes specifically highlight electrical problems rather than mechanical faults, indicating that there is an issue with the electrical components that control the pressure in the CVT system. It's crucial for technicians to apply proper troubleshooting, as a mechanical failure is not the cause of these DTCs. The pressure control valve is critical for managing transmission performance and efficiency, ensuring smooth gear transitions. Identifying the source of these codes can prevent further transmission issues and maintain the vehicle's operational integrity. DTC P0966 and P0967 are associated with the continuously variable transmission, CVT, driven pulley pressure control valve. This component is vital as it regulates the hydraulic pressure within the CVT system, ensuring that the belt and pulley operate smoothly for optimal performance. The valve is situated within the transmission itself and is linked to multiple electrical circuits. It sends signals to the Transmission Control Module, TCM, which makes necessary adjustments to maintain the vehicle's speed and engine performance. When these DTCs are triggered, it is a strong indication that there is an issue in the electrical circuit rather than a mechanical defect within the valve or transmission. Correct functionality of the CVT vulnerable to these codes is essential for smooth operation and longevity of the vehicle. Several possible causes exist for DTC's P0966 and P0967. An electrical circuit malfunction could stem from worn or damaged wires in the harness connecting to the CVT-driven pulley pressure control valve. This malfunction can manifest as intermittent failures unless properly diagnosed. Poor connections, such as corroded or loose terminals on the connector between the valve and the Transmission Control Module, TCM, can impair the electrical signal, leading to these error codes. Moreover, short circuits or open circuits in the wiring harness can disrupt the flow of electricity, causing erroneous readings in the system. It is essential for technicians to systematically check each of these components to eliminate potential issues. The successful identification of the actual cause will lead to timely repairs and enhanced vehicle reliability. When DTC P0966 or P0967 is present, the driver may experience several symptoms related to the vehicle's transmission performance. These may include irregular shifting patterns, a delay in acceleration, or slipping of the transmission, indicating that the CVT is not performing optimally. Unusual noises, such as grinding or whining sounds when the vehicle is in motion, can also signal underlying issues. Additionally, the dashboard may illuminate warning lights associated with the CVT system, alerting the driver to potential concerns and the need for immediate attention. It's important to address these symptoms promptly, as they can lead to further deterioration of the transmission if left unchecked. Understanding these symptoms can help both drivers and technicians diagnose the issue more effectively. The first step in troubleshooting DTC's P0966 and P0967 involves verifying the problem accurately. Begin by switching the vehicle to the on mode without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to clear the existing DTCs. This resets the system and allows for new readings to be observed. After clearing the codes, start the engine and allow it to idle for at least 1 second. After this brief period, Use the HDS to check for pending or confirmed DTCs again. If either P0966 or P0967 reappears, this indicates that the failure is persistent, warranting further investigation. If no codes return, it could suggest an intermittent issue, but further inspection of electrical connections may still be needed. Following the problem verification, the next step is to determine the possible failure area related to the DTCs. First, turn the vehicle to the off-lock position to ensure safety. Proceed to disconnect the TCM 50P connector, which is connected to the transmission control module. The TCM is essential for controlling various transmission functions. With the connector disconnected, measure the resistance between test points using a multimeter. Test point 1 is located at TCM 50P connector number 14, while test point 2 is connected to the vehicle's body ground. A proper resistance reading should fall between 5.0 to 6.3 ohms. This measurement will help identify whether the circuit is compromised. If the reading deviates from this range, additional steps will be required to pinpoint the issue further. The third step in troubleshooting involves checking for possible shorted wires, particularly in the DNLS line. Begin by disconnecting the CVT-driven pulley pressure control solenoid valve 2P connector. After disconnection, you will need to test for continuity between the specified test points. For this test, use the same off-lock mode, ensuring both the solenoid valve and TCM connectors are disconnected. Test point 1 remains at TCM 50P connector number 14, while test point 2 is connected to body ground. Confirm if continuity exists. If it does, it indicates a short circuit to ground in the DNLS wire. This finding will require immediate repair to restore functionality. If no continuity is found, it means the DNLS wire is intact, and the issue may lie with the solenoid valve itself, suggesting it could be faulty and needing replacement. The fourth step centers on checking for an open wire in the DNLS DNC Plus line. Again, beginning with the CVT-driven pulley pressure control solenoid valve 2P connector already disconnected, continuity testing must be performed. Keeping the vehicle in the off-lock mode is crucial for safety during this process. For this test, you will measure the continuity between the CVT-driven pulley pressure control solenoid valve 2P connector number 2 and TCM 50P connector number 14. If continuity exists, this indicates that the DNLS DNC Plus wire is intact, suggesting the issue might be located elsewhere. If there is no continuity, it reveals an open circuit in the wiring harness connecting these two components, necessitating repair to restore proper transmission function. The fifth and final step involves checking for continuity in the DNC line. Continue with the vehicle in the off-lock mode, maintaining caution. Measure continuity between the CVT-driven pulley pressure control solenoid valve 2P connector number 1 and body ground. This connection is crucial for ensuring that the solenoid operates effectively within the electrical circuit. If continuity is present, it indicates that the DNC wire is functioning correctly. However, if continuity is absent, it signals an open circuit within the DNC wiring or an issue with the ground connection, G252. In such cases, you must repair the open wire or address any problems with the ground to ensure that the solenoid valve can function accurately within the system. This thorough investigation is essential to confirm correct operation and prevent recurrence of the DTCs. After completing all required repairs related to DTCs P0966 and P0967, it is vital to conduct a final verification process to confirm the effectiveness of the repairs. Begin by rechecking the vehicle system for any lingering DTCs using the Honda Diagnostic System HDS. If the DTCs do not return, this is a positive sign indicating the repairs have been successful. Next, Perform a real-world test to assess the transmission's operation under various conditions, ensuring that shifting occurs smoothly without any signs of slip or delay. Confirm that driver feedback is positive and no unusual noises are present during operation. This comprehensive verification ensures that all previous issues have been rectified and reaffirms the integrity of the vehicle's performance. To prevent the recurrence of DTCs P0966 and P0967, regular preventive maintenance is essential. Start by routinely inspecting the wiring associated with the CVT-driven pulley pressure control valve for any signs of wear, fraying, or damage that may affect the electrical circuit. Conduct checks on connections to ensure that there is no corrosion or loosening over time, as these can lead to electrical faults. Additionally, maintain the quality of the transmission fluid, as old or contaminated fluid can adversely affect transmission performance and may contribute to error codes. Keeping a regular maintenance schedule will not only help avert these specific DTCs, but will also enhance the overall reliability and efficiency of the vehicle in the long run. In summary, DTCs P0966 and P0967 directly point to electrical circuit issues within the CVT system of the Honda Civic. It is crucial to recognize that mechanical failures are not the root cause of these codes. Through systematic troubleshooting steps, including disconnecting connectors, measuring continuity, and verifying resistance in specific wires, technicians can effectively identify and rectify the issues. Regular preventive maintenance practices play a pivotal role in extending the lifespan and reliability of the transmission system. By understanding the components and their functions, drivers and technicians alike can ensure that the vehicle operates smoothly and remains free of DTC-related problems. Consistent maintenance will ultimately contribute to a seamless driving experience and long-term reliability. Please like and subscribe to the channel. See you next time.